Alright, so we're looking at the direct comparison test and limit comparison test. So I'm going to do two videos, one for each, just to break it up a little bit. The first thing, direct comparison test, we have to look at the series and create another series. So what I mean by that is if we look at a series, we need to come up with something comparable. So we can compare two series together. And it'll make a little more sense here in a minute. So for the direct comparison test to work, we have to have some series A and another series B. And if A is less than B, so smaller, we could say that B converges, and then that would prove that A converges. Okay, so if A is smaller than B. If A diverges, then B also diverges. So that's the two kind of ideas that we're looking at. So when we look at a series, for example, the first one here, we have 1 over 1 plus n to the second, or 2 to the n power. So what we want to do is we want to think of a series that we know how to find if it converges or diverges. So if we look at this, we could say that we know 1 over 2 to the n, we know how to find out if that converges or diverges. So what we're going to do is we're going to compare that. So right at the beginning, what I like to do is I like to say that the series 1 over, well, we need to think about which one's going to be smaller. So 2 to the n is going to be the comparison, okay? So we look at these two and we think about which one's going to be smaller or bigger. So I know if I have a plus 1 in the denominator, that's going to be a smaller number than what this would produce. So this is going to be less than. Okay. So hopefully that makes sense a little bit. And as you roll through some practice, you're gonna figure it out pretty quick, I think. So now that we know which one's smaller, so we're gonna try to prove that this one converges. Okay? Because if it diverges, then this doesn't help us, because for it to work, this has to converge, and everything smaller than it converges. If this one did diverge, the only thing I know about that is everything bigger than that would diverge. So we'd have to come up with a different comparison. But let's see if it works. So if we look at this one right here, we can say that that would be equivalent to 1/2 quantity to the n power. We've looked at several of these before. And we could say that r is less than 1. So we know it's going to converge because of the geometric series test. Okay, so if this one converges, we can say that this one also converges. Okay. And that would be because of the direct comparison test. Converges by direct conversion test. Direct comparison test. Okay? Alright, so let's take a look at this next one. So look at 1 over n minus 2. Think about something that we would know how to find if it converges or diverges. We do know 1 over n. We know that converges. Or we know how to find if it converges or diverges. So we can write that up here. So 1 over n. And let's think about this. Is 1 over n minus 2 smaller or larger? Well, if I subtract 2 from n, it's going to be a bigger number in the bottom. So this is going to be a bigger value. Well, a smaller value in the bottom would be a bigger number overall. So this is a bigger series. So let's take a look at this. Does 1 over n converge or diverge? Well, this is a p-series situation. P is 1, so P equals 1, so this diverges by p-series test. Okay, so like I said, if a series is divergent, then everything larger than that is also divergent. So we can say that this diverges by direct comparison. Okay. Let me put those little arrows on there. I know you guys can make sense of it. All right, let's take a look at this last one. So 1 over the square root of n plus 1. So this is going to be a little bit trickier because let's think about it before we start writing some things down. If we want to compare it to 1 over square root of n, because that's easy to find if it converges or diverges, because it would just be 1 over n to the 1/2 power, which is p series. And we could say that that one would diverge because p is less than 1. But the problem being is that if I know it diverges, this series would have to be larger than that series for it to work. But if we think about it, we have a situation where we're adding a number in the bottom, so it's getting bigger in the bottom, which causes this to be a smaller number. So that does nothing for us. Okay, so we need to think of another situation that would work. And the one I'm going to go to is 1 over n. So the series 1 over n, let's take a look at that. Is that smaller or larger? So if I were to plug in a value like, let's say 4, we get 1/4 over 1/3, and we know that this is going to be larger. Okay, so let's think about that. We just did this in example 2. 1 over n, we know p series, if this diverges, let me switch colors here, this diverges by p series test, and this is a larger, so we get diverges by direct comparison. So just be careful when you're picking your series that you want to compare them to, and they have to be similar, or things that we know how to find if it converges or diverges. There's no sense in making one that we don't know how to find it. So make sure if you have any questions, these can be kind of tricky to pick what series you want to use. Just let me know, get a hold of me, and we can talk it out.